In the previous video, we explored the inner workings of the Great Pyramid water pump. We found out about the various phases of the operation of this water pump. We also explored the inner workings of the Grand Gallery, seeing how the float controlled the timing and movement of the valves and when the electrolysis plates were turned on and turned off. We also saw how that float powered the electrical generating device on the step, providing the electricity to energize the electrolysis plates. Now we will turn our focus from the internal workings of this water pumping system and explore additional important aspects of the Great Pyramid water pump. We will include how water was delivered to the Giza Plateau and how water entered and exited the Great Pyramid water pump. We will also address how this water pumping system was started and stopped. In video 7, we touched upon the siphon that was used to move water from the enclosure pond into the upper end of the descending passage. Water traveling through this siphon was how water moved into the Great Pyramid structure from the enclosure pond. This siphon allowed water to enter the Great Pyramid water pump. There would have been times that the water pump would need to be stopped. Stopping the water pump would have been very easy. This would have been accomplished by opening a valve at the top of the siphon, which would break the siphon. This would cause water to stop moving into the upper end of the descending passage, causing the water pump to stop. We will look at the artificial duct that was mentioned by Herodotus in greater detail. In this cutaway view, the duct connects the enclosure pond with the upper end of the descending passage. This duct and upper end of the descending passage acted like a siphon. This duct had two valves. There was a valve at the top and another valve at the bottom below the level of the water in the enclosure pond. The valves are depicted very simply to better convey their operation. Water was moving through this duct while the water pump was in operation. To stop the pump, the upper valve was opened, breaking the siphon, and water would stop entering the construction pump. Starting the construction pump required several steps. The first step was to prime the siphon. This was accomplished by closing the lower valve. Then water was pumped into the open upper valve, filling the siphon. After that, the upper valve was closed. This restored the siphon, but the water in the construction pump was in equilibrium and there was no water being pumped. After the siphon is restored and the upper and lower valves in the duct are closed, the water level is at the red line. A surge of water needs to occur to start the whirlpool in the subterranean chamber. At this point, there is no water movement and no water being pumped. The next step is to siphon water out of the well leading to the grotto. Both valves in the artificial duct are closed, so after water is siphoned out of the passage, there will be an imbalance between the water level at the siphon and the water level in the well shaft. The next step is to open the lower valve in the artificial duct, which allows water to surge through the passages and subterranean chamber, starting the whirlpool, which starts the construction pump. The construction pump was easily started and stopped. Now we will discuss how the completed Great Pyramid water pumping system was stopped and started. Stopping the Great Pyramid water pump was the same process as stopping the construction pump. Just open the valve at the top of the siphon. The open valve breaks the siphon and stops water from entering the upper end of the descending passage. But how was the Great Pyramid water pump started? The siphon was filled in the same manner as described in starting the construction pump, but that alone would not start the Great Pyramid water pump. There was no way to siphon water out of the Grand Gallery because the Great Pyramid is fully assembled. So how was a surge of water initiated to start the water pumping system? There is nothing primitive about the Great Pyramid water pumping system. I think that the electrical generating device on the step also had a receiver. There was a transmitter outside the Great Pyramid. When energized, This transmitter turned on the generating device and the electrolysis process was started. This caused the upper pump to begin cycling through its phases. Drawing water up from the Grand Gallery created the surge of water through the entire water pumping system, and then the water pump started operating. The original builders were geniuses, and it is not far-fetched at all to contend there was a wireless method of turning on the electrolysis plates. In the 19th century, Nikola Tesla developed and demonstrated a wireless controlled boat. The builders of the Great Pyramid water pump probably used radio waves to turn on the electrolysis plates and started the water pumping process. After the siphon was primed, it would have been as simple as flicking a switch to start the Great Pyramid water pump. The siphon was used to stop the Great Pyramid water pump. This was accomplished by opening the valve at the top of the siphon. Even after the siphon was broken and the water pump was stopped, the electrolysis plates were still submerged in water. This is because the two valves at the bottom of the Grand Gallery were shut. Also, additional electrolysis plates could have been in this passage. The entire Great Pyramid structure was built to be a water pump. It was easily started and stopped. These passages and chambers were designed, built, and utilized to pump water. We call this infrastructure the Great Pyramid, which was ancient mankind's prosperity machine. Outside the structure was the transmitter designed to start the massive construction project built to be infrastructure. This water pump was started using the wireless transmitter which engaged the electrolysis plates. Starting the Great Pyramid water pump was as easy as controlling the remote-controlled boat Nikola Tesla demonstrated in the 19th century. The builders of the Great Pyramid water pump, as well as Tesla, used a wireless control box to operate each of these remote-controlled devices. We know how water was delivered to the upper end of the descending passage from the enclosure pond by using the siphon, but how was that pond kept full? Everything about the Great Pyramid's construction and operation as a water pump is the height of efficiency and sophistication. This is true with keeping the enclosure pond full. Near the Great Pyramid is a cutting in the solid bedrock called the trial passages. These passages have been compared to and roughly coincide with the lower end of the Grand Gallery. We contend that these so-called trial passages are the remains of a water pump that moved water from the base of the Great Pyramid up to the height of the enclosure pond. Although much of this water pump is now gone, it was designed to lift water from the level of the bedrock to the height of the enclosure pond. This pump was probably also used to lift water high enough to fill the siphon. This explanation gives a logical purpose and useful function to these otherwise enigmatic cuttings. Near the Great Pyramid are the trial passages. From the surface, all that is visible is three openings. The trial passages are all that remain of a water pump similar to the upper pump in the Great Pyramid. The input of this water pump is at the level of the bedrock, and the output kept the enclosure pond full. Water traveled from the trial passage pump through a watertight conduit leading up into the pond. This conduit is shown in cross-section. The trial passage pump moved water up from the bedrock to a height of about 26 feet into the enclosure pond. This easily kept the pond full and allowed for the Great Pyramid water pump to have a sufficient supply of water. Because the trial passages are all that remain of this pump, its exact dimensions and operation are up to scholarly debate. Yet this explanation gives a functional purpose to these enigmatic passages cut into the solid bedrock on the Giza Plateau. The original builders supplied water from the level of the paving stones up to the height of the enclosure pond by using the trial passage water pump. Many researchers and authors contend that there is a profound link between water and the Giza Plateau. A number of researchers, including Christopher Dunn, author of the Giza power plant, as well as others, contend that the original builders were able to deliver water to the Giza Plateau and into the upper end of the descending passage. Different researchers offer slightly different explanations of how water was made available to the Giza Plateau and to the interior of the Great Pyramid through the upper end of the descending passage. So far in this video series, an explanation has been given concerning how water moved from the level of the bedrock of the Giza Plateau up into the enclosure pond using the trial passage water pump. Also, an explanation has been provided on how water was delivered up to the height of the upper end of the descending passage using the artificial duct as a siphon. But how was water delivered to the Giza Plateau? Although there is scholarly debate among researchers like Christopher Dunn, myself, and many other researchers, there is a wide consensus that the original builders provided a system that delivered water to the Giza Plateau. I contend that water was made available at the height of the bedrock on the Giza Plateau from the ancient Lake Maurice. In distant antiquity, this ancient lake was much larger and higher in elevation than it is in modern times. Water would have moved from this lake through canals or even tunnels to arrive at the Giza Plateau. It must be remembered that water needed to be delivered only to the base level of the Great Pyramid, where it would have been pumped into the enclosure pond using the pump located at the so-called trial passages. Certainly, the level of the ancient Lake Maurice has varied through the ages. Some people have argued that the elevation of this ancient lake was not as high as the Great Pyramid, but that does not matter. There could have been one or more pumping stations similar to the trial passage water pump, if needed, along the route water took from the ancient Lake Maurice to the Giza Plateau, supplying the Great Pyramid with water. The original builders of the Great Pyramid had many methods to bring water from the ancient Lake Maurice to the Giza Plateau. This includes water flowing through a canal, the use of inverted siphons, using tunnels or passageways, and the use of aqueducts or causeways to transport water. Inverted siphons are used to transport water past an obstacle. Here is an example of a large inverted siphon. The original builders also had the option of using pumping stations where needed to move water over an obstacle. In the real world, pumping stations along canals are used where needed. Los Angeles, California is known for its municipal aqueducts that bring water to this metropolis. Some are entirely gravity-fed, yet some have inverted siphons which traverse obstacles such as canyons. Some aqueduct systems use pumping stations when necessary to move water to where it is needed or to move water over obstacles. One excellent example is the Edmonton Pumping Station in California, which pumps water over the Tehachapi Mountains. Although the exact route water traveled from the ancient Lake Maurice to the Giza Plateau is currently unknown by any of the researchers who are proponents of water being available on the Giza Plateau, this route would have included inverted siphons, canals, tunnels, and even pumping stations. Egyptology has not searched for any of this evidence because they are intractably married to the unworkable idea of some sort of massive ramp and workers with strong back muscles. The Great Pyramid was built to be a water pump, but it is not pumping water now. Sometime in distant antiquity, the Great Pyramid water pump malfunctioned. Many researchers are of the opinion that there was some sort of a powerful expansive force inside the king's chamber. Some researchers have called this force an explosion. This powerful force is attributed to have caused some of the joints between the stones in the king's chamber to expand, and also to have broken the massive King's Chamber ceiling stones. Our explanation for the cause of this massive expansive force in the King's Chamber is that the coffer mechanism used to maintain the air cushion in the King's Chamber failed for some reason. This caused the air cushion to gradually be absorbed into the water in the King's Chamber, and ultimately the King's Chamber became waterlogged with no air cushion. With additional water being forced into the King's Chamber from the Queen's Chamber, the powerful hydraulic force expanded the King's Chamber, causing the structural damage that still exists to this day. This process is similar to a cylinder on an automotive steam engine being hydraulicked, causing damage to the engine. With the broken King's Chamber ceiling stones, the Great Pyramid water pump was damaged beyond repair. Through the eons of time, unknown defilers have damaged or removed the movable parts which we interpret to be valves. With so much damage inside the Great Pyramid, this structure will never operate again as it was intended by the original builders. The mechanism to maintain the air cushion in the King's Chamber malfunctioned. Exactly what caused the malfunction is not known. We will move the water back in this chamber to better see what may have happened. There could have been a component failure that caused the coffer float to fall to the floor. This may be how the corner of the coffer was broken away. The result of this malfunction is that the air cushion would be absorbed into the water and the King's Chamber would be waterlogged. The tremendous hydraulic force of additional water from the Queen's Chamber entering the King's Chamber would have expanded the joints in this chamber and broken the ceiling stones. After this malfunction occurred, the Great Pyramid water pump would never again function as it was intended. The upper pump and the lower pump are very different from each other and serve to different purposes. The lower pump was initially used to keep the construction pond full and to supply water for the water locks. The construction pump's output was pulsating, which was adequate for that application. Using the additional water pump in the Great Pyramid structure added additional height to the output of the Great Pyramid water pumping system, but also supplied an output that was virtually continuous. This is why there were two different water pumps connected in series. There are many applications of machines that are configured to be connected in series. There are many examples of connecting machinery in series with valid technical justification for this arrangement. The cylinders of a triple expansion steam engine are connected in series instead of using just one big cylinder. Locomotive engines and trains are connected in series instead of using just one big locomotive. Even municipal water systems use two very different methods to move water, and these methods are connected in series. Most towns have a water tower that water is pumped up into. Then gravity is used to distribute the water throughout the town. People who reject the idea of using two water pumping systems in series would contend the town already has a water pump and doesn't need the extra expense or extra complexity of a water tower. They would suggest to just use the pump to supply water to the town. But in the real world, there are technical justifications for using both a water pump and gravity to move water. Using these two water pumping systems in series is a real-world solution for a real-world technical application. Others object to the idea of all that complexity to pump water. In the real world, infrastructure and industrial facilities are often seemingly very complex, but they are only as complex as need be. My experience is that people with issues about the Great Pyramid water pump's complexity are generally rather unsophisticated in their understanding of real-world technical issues. Go to a factory, a hydroelectric dam, or visit a battleship, or even open the hood of your car to see that real-world technology can appear to be complex, but it is never more complex than needed. In review, water was supplied to the Giza Plateau by the original builders from the ancient Lake Maurice. Water was made available on the Giza Plateau, but only at the height of the bedrock or at the base of the Great Pyramid. That water entered the input of the trial passage water pump and was pumped up into the enclosure pond, keeping that pond full. The only remains of this water pump are the cuttings in the solid bedrock known today as the trial passages. From the enclosure pond, water was moved into the artificial duct that connected to the upper end of the descending passage. Herodotus saw an artificial duct and wrote about it. This configuration created a siphon, which allowed for the Great Pyramid water pump to be supplied with water. Valves associated with this siphon were operated to start and stop the infrastructure we know as the Great Pyramid water pump. But how did the pumped water exit the Great Pyramid water pumping system? How was that water delivered to the point of use? After all the effort of building and operating this massive infrastructure, what was the water used for? What would justify building a pyramid-shaped machine to pump water? Why expend the effort and time and resources for such a massive project just to pump water? There must have been a massive return on investment to justify such a massive expenditure of resources. Building the Great Pyramid was a costly investment, but what could have been the return on investment to justify building the Great Pyramid? In our next video, which is the conclusion of this series, we will address how water exited this structure and how the water was used to justify the construction project we know in modern times as the Great Pyramid.